Hello, my name's Eleanor and I'm the Education Manager at Benjamin Franklin House. Welcome to this week's virtual class, which is all about Ben Franklin and storm clouds. So we're really looking forward to you participating in today's class, either by asking or answering questions or giving us your feedback, your comments. If you're watching live, then there are two ways that you can do this. The first way is to use the raise hand button. So if you either tap the screen or click your mouse, you should see a bar come up. On there should be some icons, and one of them shows a hand. And if you press that, then my friend Caitlin, who also works at Benjamin Franklin House, will be able to unmute your microphone, and then you can ask your question over the microphone. The second way you can ask a question is using your Q&A button. So once again, if you tap your screen or click your mouse and you get that banner of icons, you should see one with two speech bubbles. And if you press that, then you can type your question and Caitlin will be able to read it out, and I'll do my best to answer them. We are also recording today's session, so if you're watching this on YouTube or our website, then you can always leave a question in the comments. And at any point, you can get in touch with questions or feedback, and maybe even photos of you trying out the demonstration at home by emailing education@benjaminfranklinhouse.org. So, on to the topic of today's class, which is Ben Franklin and storm clouds. Now, on your screen, you should be able to see a lovely big portrait of Ben Franklin. Now, this is a modern painting that was painted by Michael J. Dees, originally for Time magazine. And it really shows Ben Franklin in his role as a scientist. Really, the reason he came to live in London to 36 Craven Street, which is the house we know as Benjamin Franklin House today, and that's the house you can see the little drawing of on the top right of your screen. He really came to London for his work as a diplomat, his politics. But before that, it was his science that really brought him fame. And I wonder, particularly maybe people who've joined us for some previous classes or people who know quite a bit about Ben Franklin already, can anyone share with us some ideas of what science he was famous for, any particular experiments or inventions he was known for?
We have a raised hand from Brianna.
Hi, Brianna.
I'm Rachel.
Oh, hi, Rachel.
Yeah, he's famous for electricity.
Absolutely, that's probably what he was most famous for. Thank you so much. I don't know if there are any more comments or raised hands.
Yeah, we have another raised hand.
Hi, Irene.
Hi. I think that he's also famous for the well, not so famous, but he made the flippers, which would then lead to aqua shoes, basically.
Yeah, thank you. Exactly. That was one of his first inventions, his swim fins that he made for hands, also for feet, which would then become adapted into the flippers that we use today. Thank you so much to you both. And Rachel, as you said, electricity is probably the thing he's most known for. And you might have spotted in this painting on the screen that there's some lightning in the background. So probably his most famous experiment was his kite and key experiment, where he went out in a storm and he showed that lightning was a natural form of electricity. And then from that, he was able to invent the lightning rod, which was to protect buildings from being struck by lightning and set on fire. So very important invention there. So he's associated with storms because of that experiment, and you often see him in pictures like this with clouds and lightning in the background. But he'd been interested in storms for quite a long time before that, and the things we're going to be talking about today, it was investigations that he did about 10 years before that famous kite and key experiment. So let's find out more about it. So the year was 1743, and this was when Ben Franklin was still very busy doing his first job. So we've spoken about him as a politician, as a scientist. Does anyone know the main thing that he did before that? Has anyone heard about that before? Hi, Jessica.
Hi. he was he worked for, he was a printer.
Yes, exactly. Thank you so much. You're quite right. He was a printer. So this is when he was living in Philadelphia, and he had his own printing press where he printed a newspaper and also books. One of those was his Poor Richard's Almanac, which was really popular. And you can see a picture of this on the left-hand of your screen, left-hand side of your screen. And this was like an annual publication that had all sorts of interesting things in it. It had some weather predictions, it had some tips to help you around the house, it had puzzles you could do and other amusing things in it, lots of handy little sayings, which we still remember today. So these are some of the things that he printed. So although things like his kite and key experiment and probably his more famous science came after he retired from printing a bit later in 1748, Ben Franklin was always curious and always wanted to figure out how things worked. And that's how he came to invent even the swim fins when he was just a young boy. So the year was 1743, and because Ben Franklin was interested in science and very curious, he was hoping he was going to get to see a lunar eclipse. So it was scheduled to be able to be seen from Philadelphia at 8:30 in the evening, and he was getting himself ready. Now, in our class last week, we were talking a bit about space, and I wonder if anyone thinks they can explain what a lunar eclipse is, what happens. We've got a picture of one in the process of happening in the middle of the screen. Does anyone think they can explain a bit about what a lunar eclipse is? Hi again, Rachel.
Hi. A lunar eclipse is when like part of the Earth or so like covers the moon.
Yeah, brilliant description. Thank you so much. So in this picture, it's part of the Earth covering the moon, which is why you can see some of the moon, but some is in shadow. Because remember, the moon doesn't produce its own light. The light that we see from the moon, that's actually reflected from the sun. So when the Earth is in between the sun and the moon, we can't see the moon anymore, and that's when it's eclipsed. So Ben Franklin was really excited to see this, but unfortunately a big storm started that evening. So all the clouds and rain meant that he was disappointed he couldn't see it. But then the next day he was very surprised to read in some newspapers from other cities not in Philadelphia, around Philadelphia, that they'd been able to see the eclipse. One of these was Boston, which is actually the city where he was born, where he spent his childhood. And Benjamin Franklin was confused by this because Boston is northeast of Philadelphia, and the wind that night he thought had been coming from the northeast. So he thought that was very strange. He'd expected for the storm to be in Boston before it got to Philadelphia. So being the curious man that he was, he decided to investigate this a bit more, and he wrote to his brother, who still lived in Boston, and his brother confirmed that they'd been able to watch the eclipse for about an hour before the storm came. So that meant that the storm had actually gone from Philadelphia up to Boston. So Ben Franklin was very interested in this, and he started reading about other cities and other colonies. So that's what they would have called the states then. They were called colonies, both to the south and the north of Philadelphia. And he kept doing that when there were storms over the next few years. And he realized that some very powerful storms could actually move against the wind. And he wrote about how he thought that was probably to do with convection. So that's when air gets heated and rises. And if you want to find out more about convection currents, we looked at that in our lesson all about Ben Franklin and the Gulf Stream, which you can find on our website. So he thought it was all to do with this convection, and that these powerful storms would be able to move against the main wind that they were feeling. And at the bottom of your screen, you can see an extract from a letter he wrote to a friend where he described all these investigations he did to him. So because of all these investigations that Ben Franklin did, some people think of him as kind of starting meteorology, which is the study of weather processes and also forecasting, so trying to predict what the weather is going to be like. And on the screen, we can see another portrait of Franklin where he's shown with his scientific instruments. And hopefully you can see in the back at the window, there's some lightning striking as well. So he is very often associated with these clouds and the weather. And this portrait was done during Ben Franklin's lifetime. So it's quite an old portrait, and it was by Edward Fisher. And you can now find it in the Library of Congress. So he, as we said, we could maybe think of him as like the first weatherman, but since then modern scientists have come to understand a lot more about how storms work, and also how they fit in with the water cycle, which you may have heard a bit about before. So to help us understand in a bit more detail, we need to think about the 3 states of matter. So I wonder if anyone has heard of those before. Does anyone know what the 3 states of matter are? To help you think about it, if you could think about the 3 different ways we can get water, what different forms can water come in? It's quite a tricky question, but we've got someone who'd like to answer. Hi, Louis.
Actually, it's me, Zach.
Hi, Zach.
They are gas, liquid, and solid.
Exactly. Thank you so much. Exactly, gas, liquid, and solid. So with water, when it's gas, it's like water vapor, like you might see in steam coming out of a kettle, and liquid is the normal water that we drink, and then solid water is when it's frozen as ice. So let's look a little more closely at those 3 different states. So at the bottom we've got solid, so that's shown as a lump of ice, like we were talking about. And the rectangle underneath the word solid, that's to show you what the particles inside a solid look like. So when something is solid, it's the particles stay in one place, and they're quite close together and in a regular order. You can see they're in rows and columns. And a solid material, you can hold on to it, and it tends to stay in one place. Now, does anyone, there's some arrows and some words that are helping us remember these things, but can anyone describe how a solid turns from a solid to a liquid? Anyone think they can describe how that happens? Think about how ice turns into water. Hi again, Jessica.
Hi. I think it melts.
Exactly. And how does it melt? What makes it melt?
Heat.
Exactly. Thank you so much. So you heat the solid, and that gives the particles energy, and then it melts. And if we move to the picture of the liquid on the left-hand side of the screen, and you can see in that rectangle that now the little circles which are representing the particles inside the liquid, they're still quite close together, but they have a bit more space between them, and they're not organized in quite such an ordered way. So liquids can flow and be poured, and then they're not very easy to grab hold of. Now, who thinks they can explain how the liquid then turns into a gas? So I mentioned the kettle before. Who knows that word to describe what's happening to that water, some of the water inside a kettle when it gets heated and boils? Hi, Rachel.
It evaporates.
Yeah, exactly. Thank you so much. So it evaporates, and then moving to the gas part of the diagram, which is on the right-hand side, you can see in that rectangle we've got the circles or the particles within a gas, and now they're really starting to spread out and are all over the place. So gases are often invisible, and they don't have a fixed shape. So for all those changes from solid to liquid to gas, what was happening is we were giving the water heat, and that was giving it energy, and that was making it change that way. Who thinks they could describe how it would then change back the other way, the changes of state going back the other way? So how a gas becomes a liquid, or how a liquid becomes a solid? Who thinks they can explain that? Irene?
So the gas goes down, and it comes down out of the air, so it becomes a liquid, and then it condensates, and then the liquid freezes to become a solid.
Fantastic, thanks for using those science words as well. Exactly, so when the gas cools down, it condenses, and you've probably seen this if you're ever in a car or a bus, and you get kind of almost like a mist on the windows, and sometimes some little water droplets falling down. That's when the water vapor in the air has hit the cold window and has cooled down and has condensed back to water. And then the same thing happens turning liquid solid. It gets colder, and that's how it freezes. So for example, when you put your water in an ice tray into the fridge, and it becomes ice cubes. Very well explained, thank you so much. So let's think now about how these changes in state fit into the water cycle. So I'm going to show you another diagram now. We're going to think about what happens at the different stages. So let's start off on the left with the ocean. So the ocean contains 97% of the world's water, and it's getting, you can see in the diagram, it's getting heated by the sun. So who can remember the science word to describe what will be happening to the water from the ocean? What would be happening to it if it's getting heated by the sun? What would it be turning into? Hi again, Zach.
It's me, Louis.
Oh, hi, Louis.
Evaporation.
Brilliant, thank you. It would be evaporating, and it would rise up as a gas. And then as it rises up, the further it gets from the ocean or from the earth, it's getting colder as it goes higher up into the sky. And as it cools down, then the next thing would happen. Who remembers what happens when a gas turns back into liquid? Who remembers that special science word? So it evaporates into a gas, but then when it cools, it turns back into a liquid. Hello, is that Maisie?
Yes, it's Ethan. It's Ethan. Condensation.
Yeah, brilliant, thank you. Condensation, and that's what clouds are. That's what we're seeing happen with clouds. So so the rain has gone into clouds, and then as the wind pushes it over the land, it gains more and more water, and it gets really dark and heavy and full of water. And when it gets too cold, the cloud can't hold all that water so well anymore. So it falls as rain, or if it's very cold, what would it fall off as instead of rain if it's very cold somewhere?
It would come down as hail or snow.
Exactly, so it will have frozen and come down as hail or snow. Thank you. And the science word we use for that is precipitation. So we'll just remind ourselves, so the heat, the sun heats the water, and then it evaporates as a gas, and then the gas cools as it rises in the air and condenses into the clouds. And then when the clouds become really full or quite cold, then precipitation happens, and that's when rain or snow falls. So thinking about how it's called a water cycle, what do you think happens after the precipitation stage? How does it get back to the ocean so it keeps going round in a loop? Hi, Jessica.
Hi. I believe it is called a water cycle because it happens over and over and over and over and over, and it never stops.
Yeah, exactly. And so when it falls, some of the water goes into the ground and gets taken up by the roots of plants, or goes into the rocks deep in the ground, but a lot of it falls into the streams and the rivers, and those will eventually go back into the sea and out into the ocean, and it all starts again. So the water cycle is really, really important for us, and is a big part of how life on Earth functions. So great, thank you so much. There was so much participation there, that's fantastic. So one last note about something Ben Franklin said connected to this. So in that same letter he wrote to his friend that we looked a bit about earlier, he also spoke about how there was a line of big mountains not very far from the east coast of America. So hopefully you can see those on your screen. And he thought that had something to do with those powerful rains that you would get on the northeastern coast. And he was right, because when that hot air that's rising off the ocean meets mountains, it has to rise, it gets forced up very quickly and will cool quite quickly, and then rain or snow has to come down. And meteorologists, so those scientists who study the weather, still look at those northeastern storms in that area of the United States today, and they mostly happen between September and April. So does anyone have any questions about anything we've looked at with Ben Franklin's study of the storm clouds, or the water cycle, or the states of matter? Hi, Louis, or Zach.
It's Zach. And
Hi, Zach.
how does the weather form the mountain? I would have thought it would be because of the tectonic plates.
Oh, sorry. I'm sorry if that wasn't clear. So no, the weather doesn't form the mountain. You're quite right. Those mountains would have formed because of the tectonic plates meeting under the earth. But the fact that mountains are there is part of the reason you get those very powerful storms, because when the hot water comes in from the ocean, from the sea, because the mountains aren't far away from there, it quite quickly has to gets forced up into the air and gets cooled quite quickly and then comes down as rain. So hopefully that cleared it up. Thank you for asking that question. So now we've learned more about Ben Franklin and storm clouds and what scientists know about storm clouds today. I'm going to show you a quick activity that you can do at home to make your own storm cloud in a jar. Okay, so you're going to need a few items for this. First of all, you need a jar, so it could be an old jam jar. This is an old mayonnaise jar, and it's filled almost to the top with water. Then you need some shaving foam, and ideally some blue food colouring, but it's quite hard to get food colouring at the moment. I think a lot of people are doing baking. So if you can't find food colouring, you can also use blue ink. So I've got some ink cartridges from fountain pens, and a bit earlier I cut these open and put them into a little container. This is actually an egg cup, and mixed it with some water. Now, ink and food colouring, it can stain your clothes or the table, so do make sure you roll up your sleeves and maybe have a tablecloth or something else protecting the surface. So you need those things, and then ideally if you have some sort of pipette like this, but you might not have this at home, so you can use a teaspoon as well. So what we're going to do is we're going to create our cloud by, we're going to shape the shaving foam first, and then I'm going to squirt it into the jar and we're going to create our cloud. Okay, so we've got our cloud now. And the next thing we need to do is take the food colouring or the ink, if you're using ink, and then we're going to drop some of that into the cloud, and we're going to see it starting to fall down a bit like rain. So it may take a little while for the food colouring or the ink to kind of start dropping down, but we'll just let it start to fall. Okay, and hopefully you can see it starting to fall down like droplets in a rainstorm. So I've gone for blue, but you could always get a bit creative and go for some multicoloured rain if you like, if you have different kinds of food colouring or different coloured inks. So hopefully you can see it starts as a bit of a clump of blue, but now it's starting to separate and the little droplets are starting to fall down like a rainstorm. Okay, so that brings us to the end of our class and our demonstration today. Did anyone have any more questions, either about how to do the demonstration or about anything we learned in the class today? Hello.
Hi, it's Louis.
Hi, Louis.
Is it possible for gas to turn to a solid without going through a liquid?
Thank you so much for asking that question. We didn't actually go into that. You might have seen that was a little bit described on the diagram. That can happen, and we call that, when it goes from a solid straight to a gas, we call that sublimation. So going straight to a gas, it has to be heated very quickly. So that's what happens if you've ever seen dry ice. That's what's happening to create dry ice. So we call that sublimation when that happens. Thank you so much for asking that. Fantastic, and thank you for your comments. That's lovely to see those coming in too. Hi, Jessica.
Hi, my question is, can you still make one of those without shaving cream?
Yeah, I mean, you would still get the droplets falling down. You just wouldn't have the kind of cloud effect that the shaving cream is creating. Great. Thank you so much again to everyone for joining. Next week, we are going to be looking at one of Ben Franklin's inventions, the long arm, and we're going to be making our own. So I do hope you'll be able to join us for that. That's next Tuesday at the same time at 3 p.m. And as I said, if you ever have any questions, do get in touch via email to education@benjaminfranklinhouse.org. And you can always look at some of our past classes by going to our website, www.benjaminfranklinhouse.org. Thanks again, and hope to see you next week. Bye.